Hello, third grade scientists. I am so excited to be able to work with your teachers and help you learn a little bit more about force and motion and work. And I know you've already been learning tons of important information, so let's review some of that, okay? I just said we're going to learn about force and motion, so let's talk about what those two words mean. What is a force? What do you think? That's right, it's either a push or a pull. And remember, a pushing force is something that moves something away, and a pulling force is something that brings something closer, right? So that's what force is. And motion, that's just the way things move, right? So those are the things we've been talking about. And we've also been talking about this word here, work, okay? Now I know when we first started learning about this, you might have thought about work as like schoolwork or yard work or things that are really hard to do. And sometimes work can be hard, but sometimes work is easy. And in science, work means something different than what it does in those other situations, right? In science, work has to have two things. There has to be a force, so a push or a pull, and it has to make something change positions or move or have motion, right? So if there's a force that causes something to move or change positions, then work is being done, okay? So like, watch this. I am pushing the marker away from me. Am I doing work? Yes, I am, because the force is a push, and is the marker changing positions? Yes, it is. Is that hard for me to do, to push my marker away from me? No. It is not hard, but it is work because there's a force causing something to change positions, right? And I know you guys already know all that. You are experts at this already. So now we're just going to do a little experiment to see if work can be made easier. So before I talk to you about what we're doing, I just want you to make a hypothesis, because remember, as scientists, we make hypotheses or predictions about what's going to happen. So I want you to stop and I want you to think, can work be made easier? Even if it's not very hard, can it be made easier? What do you think? I want you to stop and think and make that hypothesis, lock it in your brain, share it with a neighbor at school, share it with your families at home. Make your hypothesis about what you think we're going to discover today. If you think work can be made easier, or if you think work can't be made easier, okay? Everybody got your hypothesis? All right, so now we're ready to go. What I've got here is a little machine that I've made called a lever, okay? Now a lever is just something used to lift things, really. And I don't know if you can see this word that I've written on this tape. It's a pretty old It's a pretty old lever that I've used a bunch of times, but it says this is the load. That means this is carrying what we're going to try to lift, okay? And our load is just one of these big pink erasers. That's what we're going to try to lift, okay? And we're gonna measure how much force is needed to lift this load on the lever. And what we're gonna use to measure the force are these paper clips. So we're gonna be putting paper clips into this cup one at a time and counting how many it takes in order to lift this load off of the table, okay? And we're gonna do 3 different times. So this wood block right here is what we call the fulcrum of the lever. It's kind of like the middle of a seesaw or a teeter-totter, okay? That's the center point of the lever. And we're gonna move it to 3 different positions. We're starting here where it is 8 inches away from the load. Then we're gonna move it 6 inches away, so a little bit closer to the load. And then we're gonna move it 4 inches away, even closer to the load. And we're gonna record how much force is needed each of those times, okay? Are you ready to do this with me? Get your counting brains working and your eyeballs ready to watch so you don't miss anything. And we're gonna count with me, and I'm gonna record the data here on my chart, okay? Are you ready? Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, we're already at 10, and my load or my eraser hasn't lifted at all yet. So let's keep going. 11, 12, 13, 14, 15. Now I know some of you might be making a connection. This seems a little bit like when we measured mass at the beginning of the year and we used a balance, right? A balance is a special kind of lever. So it's kind of the same thing that we're doing, but just a little bit different, because today we're not measuring mass, we're measuring force, and we're at 15 right now. So let's keep going. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, still not moving yet. 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Oh my goodness, I gotta go back for more paper clips. Go ahead and make a prediction about how many you think it's gonna take to get this thing to lift. We're already at 35 and hasn't moved at all. So I wonder how high we're gonna have to go here. Let's continue. Here's 35, 36, 37, 38, oops, 39, 40, 41, 42, 43, 44, 40, ooh, these are stuck together. Let's just do it. 45, 46, 47, 48, 49, 50. Have we already passed your prediction? If so, that's okay. Let's adjust it. We're already at 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. Oh, it moved a little. I think we're getting close. We're at 60. Make your predictions. We're almost there, I think. We got to get the load to lift, not just slide a little bit. But here we go. 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73. Oh, I thought we were close. 74, 75, 76. Whoops, that one fell. 76, 77, 78. Whoops, 78, 79. Ah, look at that. We finally lifted the load off of the table, and it took 79 paper clips. So I'm gonna write that here. 79 paper clips. That's the amount of force it took to get that load to lift. That was kind of a lot of force, wasn't it? Oh my goodness. Well, now we're gonna dump these all back out. Ah, I'm making a bit of a mess, that's okay. Dump them all back out, and we're gonna start over. But this time, we're moving that fulcrum, or that little center block, to only 6 inches away from the load, okay? So when it was 8 inches away, it took 79 paper clips to the lift. We moved a little bit closer, so I want you to go ahead and make a new prediction. I know we're doing lots of predicting today. Make a new prediction about how many paper clips you think it's gonna take to lift the load. Do you think it's gonna be more than 79 this time and it's gonna take more force? Or do you think it's gonna be less than 79 this time and take less force? Give you a minute to think, make that prediction, lock it in your brain, share it with people around you. Are we ready to go? All right, here we go. Starting back over. See how many it's gonna take to lift this load. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It keeps sliding a little bit, so I think we might be getting close already, but I don't know. That seems pretty fast. So here we go at 15. If we've already passed your prediction, you might need to change it. Or if you think you need to adjust it because it's ready to go, you might need to do that too. But right now we're at 15. Here comes 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Ooh, it's moving down here. Do you see it wiggling? Let's keep going. 28, 29. Oh, it lifted a little bit. Did you see that? 30 paper clips. 30 paper clips. We got to lift the load off the table in 30 paper clips. Look at that. 30 paper clips. So if it's less paper clips, then scientifically we would say that that took less force. And what do you think? If we are using less force, is that easier or is it harder? That's right, it's easier. The less force you have to use, the easier something is to do. And I know lifting this load isn't hard, like other things in the world are hard to do, but when it was 8 inches away, it was harder than it was when it was 6 inches away. Okay, scientists, so now we're gonna do it again, but we're moving the load to only 4 inches away from the center point, okay? So look at what happened here. We went from 79 paper clips to 30 paper clips. I wonder how many it's gonna take for the load to lift at only 4 inches away. Make your predictions, lock them in your brain, share them with people around you, and let's see what happens here. This is so exciting. Okay, are you ready? 1, whoop, it slid again. 2, it keeps sliding, I'm gonna hold it in place here. 3, 4, 5, 6, 7, whoops. Oh, goodness. Up. 8. 8 paper clips. Can you believe that? 8 paper clips and it is lifted off of the table. Oh my goodness. 8 paper clips. That is way less force than when it was 8 inches away. And it's even way less force than when it was 6 inches away. So remember we said when you're using less force to do your work, to make something move, that it's easier work. So remember way back to the beginning when we asked this question, can work be made easier? What was your hypothesis? Did you think that yes, the work could be made easier? Or did you think no, that couldn't happen? Well, either way, it's okay, because sometimes scientists make correct predictions and hypotheses, and sometimes they make ones that are wrong, but that's how we learn, right? So I think we have learned today that less force equals easier work. Okay, so then the opposite of that must be true. If you're using more force to get something to move, then that's going to be harder work, right? Like I would have to use a whole lot of force to move a big stack of chairs, but I wouldn't have to use very much force to move this box of paper clips across the table, right? Either way, it's still work because we're using a force to change something's position, but it's easier to push the box of paper clips because that uses less force than it is for me to move the big stack of chairs because that uses more force, okay? I hope that makes sense, and I hope you understand a little bit more about how work can be made easier, and I can't wait to see you next time for another experiment that we're gonna use to prove whether or not work really can be made easier. Bye, guys.